Hello class, we're going to look at complex numbers in this lesson. Really for this course this should serve as review, and that's why we're kind of going back to the preliminary chapter there to look at complex numbers a bit, because moving forward we're going to be doing some lessons with quadratic equations and we're going to get complex or imaginary answers. So question, what are they, right? So the idea being, when we take the square root of a number, we are used to problems like this. Square root of 25 is equal to 5. We know that because 5 times 5 is 25. Now we also can say, in words, what are the square roots of 25? And that would be 5, because 5 times 5 is 25. But negative 5 would also work, because negative 5 times negative 5 is 25. So the question is, what if we're going to take the square root of a negative number? Square root of negative 25. So with real numbers, there's no answer for this. There's no solution because there's no number times itself that's negative. Because when you multiply two positives, it's positive, and when you multiply two negatives, it's positive. So it begs the question, what if we wanted to solve a problem like that? And that's where imaginary or complex numbers come in. So the term complex numbers refers to all combinations of real and imaginary numbers. With imaginary numbers, what we've determined in the past is we come up with the letter I to represent the number that when you take it times itself, you get negative 1. That's what I have in blue here. Here's the definition of the imaginary number I. The name imaginary numbers is a bit of a misnomer because it sounds like they don't exist, but we have to kind of free our minds a little bit and realize that, we're used to regular operations, addition, subtraction, multiplication, and how they work with regular or real numbers, but this is something that's like outside that realm for us. So we're actually able to solve a lot of problems then that we would normally, in the past, we would say, there is no solution, or we would start to then use the phrase no real solution, but there are imaginary or complex answers. Application of this would be electrical engineering and some design with that. They use complex numbers to work through that. Now only one other thing in this introduction here, and that's about standard form. So standard form is referring to the fact that when you have a real number, like say 5, and you add to that an imaginary number, like say 2i, so 2 times the square root of negative 1. We can't combine them. They're not what we call like terms. Standard form is to have the real part followed by the imaginary part. Now with fractions, it comes into play a little bit different, because what if I have 5 plus 2i all over 3? Now I like that. That doesn't seem bad to me. It's saying take 5 plus the quantity 2 times the square root of 1 and divide that by 3. But what's considered standard form is to split that fraction and have an exclusive real part, which would be the 5 over 3, plus, and then divide the imaginary part by 3 too. 5/3 plus 2/3 I. And you're going to see that in a lot of questions that you work on. So next we're going to move on to operations.